Good evening, everyone, and you're very welcome to this evening, an event sponsored between Analog Devices and our good friends in ANSYS. So we have the ANSYS CEO here, Ajay, who I'm sure will be speaking to you later on. So we've had some pretty incredible sessions in this world of physical to digital. Analog Devices, as you probably know, is a very strong sensing company where we've got the physical data capture and then transforming it into digital. In this world of pervasive simulation, we're thrilled with ANSYS to be solving the most difficult simulation problems. So you'll see in many different areas. Tonight's topic, I think, is on autonomous transportation, which is one of the very early adopters, but there's lots more to go in other areas. So I think we've got a great panel here to explore this topic. We've got Judy, who's going to keep everybody in the right place and make sure that they behave themselves. The fights won't be too bad, at least in the beginning. And I think we've got representations from Neo, Ford, Analog Devices, and obviously ANSYS and McKinsey, if that's correct. So we've got a great discussion, I think, lined up, and I think without further ado, we'll send it over to the panel, and I think we should have some very interesting discussion. So here we go, Judy.
Thank you, Martin. All right, so my name is Judy Curran. I will be moderating this panel, and we have a great group of experts here. So we're going to start by having them introduce themselves and then talk about what they currently do in their roles today with regards to autonomous. So why don't we start with Jamie?
Okay. Hello, everyone. I'm Jamie Carlson. I guess I started my career in aerospace, which I think is relevant for autonomous driving. There's a lot to learn there. But after that, I worked for a tier one called Gentex. Then I was the founding engineer at the Tesla autopilot team, worked at Apple on their special programs, and now I've been at Neo for about 3.5 years. So at Neo, I'm responsible for the ADAS and autonomous driving programs. For anyone who doesn't know what Neo is, we're a Chinese-based EV car company. If you're in this space, you should know us, but we've got 2 vehicles in production right now. We just launched our 3rd vehicle, and hopefully we're going to be selling here in the US here in the next number of years. So.
All right, thanks, Jamie. Craig?
Hi, I'm Craig Stevens. I'm Director of Controls and Automated Systems in Research at Ford. And as the name suggests, it's sort of everything controls, powertrain controls, hybrid electric controls, ADAS systems, autonomous vehicle research, and robotics. And I've been with Ford 32 years, so that just makes me old, I think.
Not at all. I'm Chris Jacobs. I'm the Vice President of the Autonomous Transportation and Automotive Safety Business Unit at Analog Devices. In that role, I'm responsible for radar, LiDAR, and inertial MEMS technologies as it pertains to autonomous driving and different types of autonomy applications like AGVs and construction equipment and things of that nature. And I've been with ADI for 25 years. And we're not. So.
Hi, good evening. Russell Hensley. I'm a partner with McKinsey. I've been with McKinsey about 18 years, and prior to that spent 12 years, mostly with Ford and then with Ricardo, designing and developing engines, the old-fashioned kind. At the firm, I'm co-lead for the McKinsey Center for Future Mobility, where we try to be a think tank and help shape the debate around the future of mobility, whether it's autonomy or electrification or connectivity or shared mobility. And just try and, again, inform the debate in this high period of uncertainty, which I look forward to discussing.
Good evening. My name is Walt Hearn. I'm with ANSYS. So a little bit about ANSYS. We solely focus on simulation. And around autonomy, what we recognized early on as a company is that there's a really big challenge with bringing autonomous cars to market. And the currently way it was being done was drive physical miles, right? So we headed down this journey at ANSYS of building a simulation platform so we could simulate all aspects of autonomous vehicles, so we could remove physical miles and move them to virtual miles, so we could help speed up the pace to autonomy.
All right, so that's our expert panel. So on autonomy, when you first think about it, there was so many announcements about vehicles that were going to be on the road in 2020 and 2021, and now we're hearing delays because, as it turns out, this is much more complicated than we thought. So we wanted to talk about the technology associated with autonomy, the business model, and also about customer acceptance. So we debated on what to start with, and we said, you know what, let's start with the business model. One of the things we all know for sure it is very, very expensive and difficult to come out with an autonomous vehicle. So the way we're going to work the panel is I'll call on one person to start the dialogue, and the rest of these guys will jump in, and then we'll move on to the next topic. So starting with the business model and setting the stage, Russell is going to start us off.
Yeah, thank you, Judy. I think just very briefly, to give this a little bit of structure, I think you've got to think about what's the problem that you're trying to solve. I think there's a number that we all know, which is around 37,000 lives are lost each year on the roads in the U.S. It's a $200+ billion cost to society each year, just as a statement. I think if we look at where we are today, if we look at the last 10 years and how we've gotten to this place, it's fascinating to look at the investments that have actually gone in. On an average year, the industry, and when I say industry, I mean the traditional auto industry, spends around 120 billion, about 90 billion at the OEM and about 30 billion at the supply base on product development and R&D. So that's investment in new product. What's actually happened over the last 10 years is something that's never happened before. In addition to that, 220 billion has been invested. 90+% of that has actually come from outside of the traditional industry. There are a lot of players, non-traditional players, that are viewing the future of mobility as a very, very attractive space. If you break down the 220 billion, around 55 billion has gone into e-hailing alone. Around 54 billion has gone into autonomous. Around 37 billion has gone into semiconductors, software, to give you a sense. So again, with that level of investment, again, it certainly gets your attention that something is going to be fundamentally different. In addition, if you look at the innovation that's going into the vehicle today, over 90%, 85 to 90% actually, of the innovation that goes into a vehicle, whether it's a car or a truck, whether it's moving people or whether it's moving goods, is actually software, which again is fundamentally different from back in the good old days, 30 years ago, 40 years ago, whenever it was, when it was primarily hardware. So that is fundamentally different. So, what we've had last 5 years maybe, it's kind of been the dawn of the EV. I believe the next decade will be, where the EV comes of age and we start to get decent volumes of EVs because the policy is behind it and the consumer awareness is there and the choice of vehicle is there. Now, in terms of what's happened with EVs and why I'm giving you this example, EVs, battery prices were $1,000 a kilowatt hour 10 years ago. Right now, batteries, it depends who you talk to, but they can be $150 a kilowatt hour, they can be $90 a kilowatt hour. It depends, again, what contract you have, what supply you have, again, the specifics of the battery. But there's a profound drop in cost. Now, LiDAR, again, take the parallel. LiDAR has got to go through the same journey. You could say, again, Walt and I were just having a discussion earlier, it's come down from literally, 70s, 80s of thousands down to whatever it is today, 250. That's got to continue. Cost is a critical part, but you've got to also have the use case. The use cases for autonomy are going to be very different from probably what we have today, and that is something, whether it's a consumer use case when you're moving people, whether you're moving goods, those use cases are different. And again, we're going to have to go through quite a significant learning. If you play the movie forward, 2030, again, no future facts. Our crystal ball is no better than yours. If you run some scenarios, it could be that you've got 2% of the market, 20 million vehicles on the road are AV capable. At one level, probably level 4 by the end of the decade. It's worth about 1.6 trillion, to give you a sense. And if you break that down into 3 lumps, well, one lump being actually designing, developing, producing, and financing the vehicle, that's about 40% of the 1.6 trillion. Another 30% of it is actually the AV services that go with it, and another 40% is actually operating the fleets. So just to give you a sense, that's moving people, and it will be driven, and the central point will be from cities.
All right, thanks, Russell. Anybody want to add to?
So I think you have to look at it from other perspectives around what's changing in society. It's not just around the trends that were spoken about there, but if you look at cities, right, and the congestion in cities, look at the choices that people are making. Many people who live in cities are choosing not to own a car. You look at the new generation of drivers that are potentially coming in to buy our products, and many of them are choosing not to own a car. If you look in cities at how much congestion is caused by people trying to park, and then on top of that, you've got the things that we all like, right, in terms of having our packages delivered the next day, which again adds to congestion. And if you look at it from the perspective of cities, it's not a good picture, right? With congestion getting worse. And for us as a car company that was founded on the principle of helping people to move, it's kind of hard, right, for us as a car company. So that drives us to think about not just the vehicle, but how the vehicle is used, to the very first point that you made in terms of moving people and moving goods. And then the journey on the way there is about making things safer.
All right, so we talked about various business models. Any comments on which we think is going to be better for our businesses, moving people or moving goods? Any thoughts which way we might end first?
Well, I was going to add to what Craig mentioned here, because it's not all about automotive, Judy. I think that there are use cases and business models around automated ground vehicles, warehouse robots, construction equipment, in which there are clear business models that will, I think, generate revenue for the industry overall. So it's not all hanging the hopes on level 4 or level 5 autonomy. These types of technologies that we're going to speak about today can be used broadly across the variety of different applications. And I think that that would serve to actually accelerate the adoption of some of the technology and maturing the technology overall and getting us to a more profitable place in the long run.
I think, Judy, just to close on it, I think one of the absolute critical inputs in all of this is utilization. If a vehicle, whether it's in a factory or whether it's on the streets and whether it's moving people or goods, if utilization isn't high, the business equation doesn't work. Also, when you're moving people, if the pack density, it's very difficult to have a full vehicle with one head in it. That to make the economics work, the sweet spot is 6 to 8 people. But again, you've got to have that around the clock, which in not many places that happens. So utilization is very, very critical. And the drivers of utilization, you're going to have consumer acceptance. And it's a very, very new thing to consumer acceptance. Consumers, we find they'll give up the second car, but giving up the first car that's their insurance policy. That's what they need around when grandma breaks a leg or whatever else, and they got to get to hospital. So.
All right, so I'm going to move now to the technology. But before I do that, we have an instruction when we talk, lift our microphones closer to our mouth so the audience can hear us better. All right, so let's talk about the challenges of the technology. We've set the stage for the business model and the choices we have there and the utilization. I want to start with LiDAR. LiDAR being the most expensive part, probably, besides the software of the system. And so why don't we talk about, in each one of these technologies, the state of the technology, innovations that we still need to figure out, and what we think is important as next steps in that space. So with LiDAR, Chris, do you want to start us out?
So first, I'd like to state that LiDAR is an absolutely fundamental sensing modality for autonomous vehicles. If you look at camera and radar, LiDAR is a complementary technology that is required in order to cover, I think, the complex use cases associated with highly automated vehicles. So having said that, I think that there is a business imperative to address, as Russell mentioned, the $70,000 or $80,000 modules that are in place today to get to something more appropriate for broader adoption in personally owned vehicles. So if we look at LiDAR, I think it's fundamentally wrapped up in size, weight, and power of these systems. There's a lot of fragmentation in terms of how these LiDAR systems are being architected, and I think over the next decade you're going to see a consolidation around these architectures, and that will lead to higher levels of integration, especially in the semiconductor realm. And I think that that's going to drive a lot of cost out of the system. Obviously, cost is a very fundamental piece of this, but we also have to continue to push on the improvements of performance. LiDAR needs to get to that sub 1 degree angular resolution to give you that clarity around the scene of the car. You cannot necessarily achieve that today in an automotive framework that is ruggedized and has that right cost footprint. So I think LiDAR is probably one of the richest areas of innovation to bring all of these different capabilities to bear to reduce the size of the module, reduce the weight of the module, reduce the power of the module, reduce the cost of the overall module. And I think once we get to these $250 price points that Russell was mentioning, then I think that you're going to see this much more broadly adopted in these automobiles of the future.
All right. Any other comments on LiDAR? No. I did note earlier we were talking, there's a lot of new players coming into LiDAR. We talked about with Bosch, Sony, so everybody wants a piece of the action. So watch the space as we approach the 250. Let's go to cameras. Another big piece of our autonomous vehicle. What's new in cameras and what else we need to do there? Walt.
Yeah, so I think it's important when we look at the sensor suite that we're looking at from cameras, LiDARs, and radars. It's ultimately about being able to solve all the different failure modes, right? And so, whether it's solar glare is a major problem, fog's a major problem. And so when we look at camera, we have to look at different ways to tackle these challenges. And I think FLIR's here as well. And FLIR's done something that's very unique, is bringing thermal cameras into autonomous. And their thermal cameras can pick up, people at night. It can pick up solar glare. It can pick up all of these different failure modes. And so when we look at it, it's really about capturing all these edge cases and using the sensor suite to tackle them. But with camera and with thermal cameras, I think that's going to help us get there much faster.
Maybe to add to what Walt said and tie even the LiDAR points in, I think the last 12 months is the first time that we're seeing any kind of visibility on any products that actually have the angular resolution, some semblance of something that looks like it's going to be a price point that can be achievable, that we're all kind of waiting for. And the same thing is happening with camera as well. According to our analysis, based at the speeds within our ODDs that we want to be able to travel, we've really been yearning and waiting for an 8-megapixel camera that if you're a mobility as a service provider, you can slap in some non-automotive qual part. But now for many of us in this space that are really looking for automotive qualified parts, and we don't want spinning pieces in the LiDAR and these types of things, I think this actually ties back to the earlier point on the business model for maybe why we've been wrong on saying 2020, 2021 is going to be the place, because now we begin. Now is the time that we can truly begin collecting data with sensors that might actually see it into production, hopefully in just a couple of years, as we've been saying now for the past 5 years.
I agree. Thanks, Jamie. Anybody else on cameras? All right, next technology, part of the system is our radar. Radar has been around for our ADAS system, but more expectations for autonomous. Chris, you want to take that?
So I think radar is the utility player in many of these sensing modalities. It is going to be a standard fitment on automobiles starting in 2022 with the automatic emergency braking regulations that are coming out. That is going to require a radar solution largely. But in my mind, the performance is not necessarily sufficient in order to achieve full autonomy. And I think it's getting better over time. I think that to Russell's point, the radar technology has gone through the cost reduction roadmaps over the years, and so I think that is well understood that the size, the weight, the power, and the cost of radar systems are appropriate for mass market automotive. But how can we achieve higher levels of performance but still stay within that reasonable cost envelope here? Because I think that you're going to see in highly automated vehicles anywhere from 6 to 8 radar modules per car in order to give you that full 360-degree coverage around the car. So I think the real challenge is how can we continue to bring more radar performance to these applications, but not necessarily dramatically increase the cost. And so that will, I think, also lead to some unique software and algorithmic solutions that would sit on top of these radar hardware modules in order to eke more performance out of the system overall. I think that what you're going to want to see in these imaging radar systems is a higher levels of resolution, both angular and range resolution, so radar systems can move beyond just being an object detection technology, but something that could be used for object classification as well. And I think that that's going to be a very interesting technology, because if you can identify not only an object, but it's a bicycle and its intent at the edge, that gives the car more time in order to execute any kind of invasive actions in order to avoid an obstacle. And so I think that you're going to see a lot of improvements along those lines that would achieve lower latency and a lower false alarm rate.
Any other comments on radar? All right, so now we got LiDAR, we got cameras, we have radar, maybe we have some ultrasonics. Now we need to talk about sensor fusion. How do we combine all this data and get to knowing a little bit more about what the car is doing around us. So Craig, you want to talk about sensor fusion?
Sure. So I agree with all those comments from my colleagues up here, and I think our interest is in really all of these sensor modalities and seeing how we can bring the information from them together to obviously give us an accurate picture so we can localize and understand what's around us. And that's a complex task because those sensors all have their strengths and weaknesses, and they are affected by environmental conditions and other factors as well. I think it's interesting when you think about sensor fusion to look at where the technology has come from. So when we were first involved with the DARPA Grand Challenge, LiDAR was considered essential for any kind of autonomy. It was the only sensor that could give us the localization that we needed. And you know, if you look back at when we were doing that work on the DARPA Grand Challenge and then look at where cameras were there and image processing and look at the gradient that's happened on image processing over the last few years, it really just shows that this is a very dynamic space. So I think it's probably foolish to predict the sensor set that we will be using 5 years, 10 years down the road, but I think it's really exciting to look at all these sensor modalities. I mean, imaging radar, right, is really interesting. I think we're still moving in leaps and bounds in terms of vision processing. So I think from our standpoint, it's more about staying up to date with the technology, tracking the different companies, whether they be startups or well-established players, and then having those sensors on our research and development vehicles so that we can then understand what are the various pros and cons and what's going to get us to that sweet spot around having the best value sensor set.
Jamie, you want to?
Maybe just add one thought to that. I think sensor fusion has been something that's been prevalent around ADAS for many years. It's been camera radar systems in cars for maybe you might know better than I do, but many years. I actually don't think there's a lot of new innovation that really needs to happen that's really going to take sensor fusion to some higher dimension where it's already at. I think the thing that needs to be talked about that is rarely referred to is how a sensor fusion system actually breaks down any kind of semblance of redundancy that you have. And so I think that actually the algorithm that you choose or the method in which you try to say that this sensing modality A and B combines to make this new sensing modality C, which is your fused sensor, this is already understood. I think really what we need to fully understand is how are you going to mix and match all these sensors in a cost-effective way that can be packaged, that can keep clean in the different environments, they can understand when they're not clean. This is, I think, the complexity that really needs some larger advancement beyond what we've already done in ADAS over the last 10 to 15 years.
Krista, do you want to add anything? No. Okay. So I'm going to add on to you, Jamie. So back to the sensors, that's the critical piece. When we talk about trajectory planning or path planning, do we feel the same way? We kind of know how to do that, like sensor fusion, that really it comes back down to the sensors. What are our thoughts on trajectory planning?
No, we don't understand it. We understand it enough to look like we know what we're doing, but the long-tailed events are what makes this challenging, and the thing that's complicated is it's very tied to your sensors and your distance and your occlusions and where these things are located in the cars, because that all has a large impact. And one of the things that we talked about previously was about some of the new AI technologies that are being built to understand whether you're an aggressive driver or a slower driver, these types of things. While I find this kind of research interesting, I don't think these are the types of game changers that we're actually looking for, because the reality is I can correctly classify you as an aggressive driver and you can, for the next 10 seconds, obey the laws. Or vice versa. You can be a very responsible driver for the last 30 minutes. And so really I think something like what we discussed previously might change the level of comfort that I'm able to provide as an autonomous system, but the understanding, the expectation is that it always needs to remain safe. And just like we drive as a human, we get it wrong all the time, but we naturally adapt. And so I think that we kind of overdo it in this space for what AI and machine learning are doing for us. A lot of this is really just optimizing what we've been doing for 30 or 40 years in the computer vision space, looking for classification, combination of the right dials and knobs to get the best result. machine learning just brings in a way to do that in a much faster way than we can do as humans.
All right. Any other comments on trajectory planning?
I guess, Judy, I'd like to add, just an addendum to what Jamie was saying is, when we look at path planning and effectively navigation capability, automobiles today don't necessarily have the hardware and the capability in order to achieve centimeter level accuracy when it comes to path planning and navigation of the vehicle itself. And I think that that's an area that needs to be addressed. So, for example, as you enter into a tunnel, your perception sensors could be impaired in some fashion. You're changing lighting conditions, so your camera could go into saturation or something like that. Your radar system could be dealing with multipath, bouncing off of the walls of the tunnel. You need another type of sensor like an inertial measurement unit, which is present in many other applications outside of automotive today, in order to continue along your path of travel and to be able to provide you a protection level around the car that it will not drift off of your path of travel. So again, not directly addressing the path planning challenge, but I think it's going to be a fundamental piece of technology that's going to be absolutely fundamental to achieve centimeter level accuracy for precision navigation types of applications.
All right, thanks. Okay, so we've talked about the sensors and the fusion and the directory planning. So now we have our car, we have all our parts, now we need to validate it. So we're all driving millions and millions of miles, so the validation is the challenge. So what do we need to do in validation to help us along?
Yeah, so the way we're approaching it, right, there's a great study that came out by RAND, and it said, look, it's going to take 275 million fault-free miles to validate an autonomous system, right? And so to drive that car, to do that validation is really going to be time-consuming. And so we believe one of the key ways to do that validation is through a mixture of simulation along with road testing, right? And so bringing the two together into an environment to test again can help really speed up the validation efforts. In some of the ways we're talking about perception algorithms is in a simulation environment, we're doing robustness testing on the perception algorithms to ensure that they're identifying objects correctly, right? Because if we can get correct object identification, then it makes the policy and software planning, much more easier to tackle. So we see simulation as a big key in the validation process.
Craig, any thoughts?
Oh, yeah, you can't argue with that. I mean, the data is very clear that if you don't have a very strong focus on simulation, you can't achieve the level of quality and performance that you're going to need to sell those features to our end customers. I think that's kind of the high-level answer I'm sure everybody would buy into. I think how do you do that testing? How do you generate enough data to give yourself confidence that you can send something to production? That's the more fundamental question. And that then brings in, what kind of physical models do you have? What's your ability to automate that testing? What's your throughput in terms of managing massive amounts of data? If you're generating massive amounts of data, how do you analyze that data, right, and pick out the events that are interesting? And there's a whole host of other issues that come with that where you start to say, well, I'd like to create scenarios, and then I'd like to manipulate those scenarios with some kind of statistical design of experiments so that I can explore other use cases or other edge cases. And I think there's another aspect to simulation which is going to be important, and it relates a little bit to the use of AI and machine learning in computer vision, is that you need a lot of data to train these models, and you can go out in the real world and try and capture massive amounts of video and so on to train your models. But when can you use simulated data to help train your models? And I think that's going to be very interesting to see how that develops.
I maybe have one thought to share that I hope I can put into words. I think the next hurdle that we're going to run into is actually the fact that once we validate, whatever that might look like, there's actually going to be a growing problem where we're going to want to, number one, we're going to want to continue to make changes to predominantly the software. Maybe, for instance, we support Las Vegas today, but tomorrow we want to support, pick your other, Phoenix, right? Do you start over? Is Phoenix a completely different binary that's deployed to just that car? And I think we need to think about it organically, that this is actually going to be some organism that grows, so to speak, in terms of the software. That's one thing. And then the second, actually, even if you're within the same ODD and you yourself, the autonomous system is not changing, the world around you is changing. So if you actually look at, I don't know, the first things that come to mind here are the, I'm sorry, the name's escaping me, the bicycles that you can share. The sharing bikes or like the Lime bikes or any of these these came out of nowhere. And these are just some examples. We can't predict what in 2 years from now or in 3 years from now. So I think what's going to be a real challenge is this completely breaks the mold from the way that the automotive industry and even the aerospace industry works today. Previously, it's define your features, implement your features, your code freeze, you validate the heck out of it, and then you don't ever want to see that again. If you see it again, it's because you have a recall, the R word, right? And so I think we really need to change the entire fundamental way in which we engineer the software and do the whole validation process. Even once we figure that out, this needs to be an ongoing effort that I think that the entire technological community needs to arrive at a solution that scales, because time is a new factor in the way that we scale a system like this.
All right, so jumping on that to one of our last topics, which we touched briefly upon, but I wanted to go back to it, which is customer acceptance. So with our phones, we accept a lot of software downloads. Sometimes they're not perfect, but we're still somewhat accepting. So the question in autonomy is, how perfect will our vehicles need to be for customer acceptance? So what are our thoughts on customer acceptance of the technology and what we need to do to get customers more comfortable with autonomous?
Maybe I can start there. I think key is trust. The customers have to trust not just in the brand they're buying from, but they also have to trust that we've done our job as engineers and scientists to deliver a reliable and robust feature. It's not acceptable to go and experiment on customers in the way that some of our apps seem to be experimenting on us. But for sure, to your point, right, we will see things in the real world that we will want to bring back and we'll want to use to refine the algorithms, but that has to come from an absolutely firm base of robust and reliable performance. And I think this is particularly true in our ADAS world today, where we see that customers may have these features and may not understand how they work. There are differences in the way they work from manufacturer to manufacturer. And I think that the customer experience of these ADAS features is absolutely fundamental to success, because that experience is what builds the trust.
Yeah, I'd like to. I'm sorry, Russell. I definitely want to second what Craig said there. I think that the standardization of these types of features from manufacturer to manufacturer, I think that the lack of standardization is going to hamper that trust building. If I get into a Ford and it operates in one way, and then a General Motors vehicle operates in a completely different way, you're not necessarily going to rely upon these sensors and capabilities in the way that you should in the long run. So I do think that that's going to definitely improve. And I think another point, and I mentioned it earlier, I think that the visual capability of drones and AGVs, I think that that's also going to allow us to not only mature the technology, but it's an outward sign to the broader consumer base that these types of technologies are viable, and they are not necessarily in safety-critical applications. And so I think that that also would facilitate a broader trust and understanding around the technology.
Yeah, I completely agree, and I think Craig, I would say consumer education is absolutely critical, right? Again, whether it's learning how to use a plugin, or what an autonomous vehicle brings, I would take a little bit of a step back and say, actually, who is the customer, not the consumer, right? The consumer is the person that's using the rideshare vehicle or using this to deliver goods, but cities may well be the customer, right? And cities may well say that, well, I want the absolute, the safest and most trustworthy system out there. I'm not going to accept the 95% solution, which again has got huge connotations on things. I think you've got an absolute, huge demand that is latent, or not latent. It's absolutely there, which is rideshare companies. And all due respect, if any are in the room, apologies, but the business equation doesn't work until autonomy comes, right? Because the pricing that we're seeing today is supported by other means. right? It's not sustainable in the long run. So therefore, autonomy is an absolute need to make ride sharing viable in the long run. So you've got a solution there, and again, the customer again is going to be only accepting of probably the best system or the best integrated system. And then again, you've got, whether it is delivering people or whether it's delivering goods. Again, this huge, and we believe that probably the goods delivery comes a little bit in advance of the people movement, but the people movement in the safe environment. A little bit of a stat, Judy, just to close from myself, but it's very difficult to survey consumers because they don't know what this is. Very, very difficult, right? You can do various tests or simulations to try and get some sense, but we find of the consumers worldwide, this is relatively consistent. The Asians are a little bit more aggressive, the Europeans in the middle, the Americans a bit more conservative. About 50% are not even willing to entertain it, right? About a third of them are willing to entertain it if the cost is less than current transportation. And then the rest, it's whether, there's actually a small percentage willing to pay a premium. There always is that sliver of a segment.
All right, thanks, Russell. All right, so that concludes my questions, and that's a perfect ending because this is still a tough job ahead for all of us. But I want to open it up to the audience now for some audience Q&A. So raise your hand if you'd like to ask this expert panel a question.
Thanks. So Emily Horn from John Deere. I work on computer simulation, so the validation side of things. Closer, sorry. I feel like I'm eating the mic. So back on the validation question, we've spent years showing correlation for structural analysis and fluid dynamics. So using synthetic data for testing and training our systems, do you think that there really is that trust internally in our companies to use that synthetic data for these algorithms? Or do you think we still have a long way to go to build up that trust internally?
I think that even if I look at the other part of my job, right, the powertrain control system, the electrified powertrains, those systems are already so complex that you can't validate them without simulation. And so I think that when we look at, say, vision processing, and we ask the question is, could we use synthetic images? I think that then poses a whole host of other questions, like how can we convince ourselves that the results that we're going to get are valid? Google's got a paper out, a couple of papers where they used synthetic data. I think it was in a robotics example to help train, and they got some good results. But I think that there are all the questions around sort of safe AI, provable AI. Those exist, and we have to build confidence around using those techniques in the same way that we have around the techniques that we use on other systems. Most embedded systems aren't provable, right? So how we're going to go about doing that is part of the challenge before we put those techniques in production.
Maybe briefly add something to that. I've always looked at validation kind of like an onion. If there was any one type of validation, that's what we would do. If there was any one type of validation that just worked, we would just do unit tests, or we would just do driving, or we would just do simulation. It doesn't even matter if you're building an autonomous car. I think in the software perspective, you start with a unit test, you might do some functional tests, some black box tests, some system tests, and you go along your path, and you try to get as much coverage, and then you have code coverage tools that tell you what you're missing as a developer to see is there holes, or do I have dead code somewhere that cannot be instructed. So we have processes for this, and I think that there's a lot that we can learn. Hopefully not just flat out doing, but I think there's a lot that we can learn from the aerospace DO-178 process and pick and choose pieces of that, because if you actually look at the whole process and you read through the 700 and some pages, that's really all that they're asking us to do, is to go in deep, like defense in-depth kind of validation testing. And so I think that simulation as a solution is wrong. Simulation as one of your tools in your tool belt is completely reasonable to rely on that layer of that onion, just like you would with any of the other methods.
Any other questions?
So we're hearing a lot about level 4, level 5 full autonomy, but then recently we're hearing about delays on level 4, level 5 autonomy. So what does the panel think about disruptive answers that might be smart highway, different to what people think today, or is it basically we keep on the path, it's just it's a little later?
Now the tough questions come. Go ahead.
So I think that's a great question, because I think that where we started our journey with autonomous vehicles, this was certainly true in Ford, was that we designed the vehicle to be able to take care of itself, right? So it was not relying on any information externally. It was not relying on GPS, right? So when we went down the HD map route, the same as everybody else, I think it's hard to imagine the HD map route being the ultimate solution, right? The ultimate solution is the car's got to have the intelligence to be able to take care of itself in the world. But one of the things we shouldn't rule out is it taking information from the infrastructure. And I think, we're seeing the earliest deployments of V2X, right, V2I, and on the ADAS side. And I think that there is a potential opportunity for what can the infrastructure do to help enable autonomy. And that might come back to the point of how the cities, right, help enable autonomy.
Yeah, I was going to say, just to add to it, I think the world that we've grown up in is, from an automotive standpoint and mobility standpoint, it's incredible, right? If you think of these guys design, develop, produce cars, by the hundreds of thousands that are incredibly reliable, and they fit just about every use case. I think that thinking is changing, where so take the city use case and take the short stint, or take it maybe geofenced, it may not be, but you will have, I think, specific vehicles that are designed for those specific applications, and that's the way that this will evolve, right? Again, it's in its infancy. This is, I believe, the decade is the dawn of the AV, right? It is the coming of the EV, if you will. Right? But again, it will be in specific use cases, and you'll see those being more and more prominent based on, again, the technology, the regulators, the city driving it, and also the economics behind it, the size of the prize, which is, again, why you see some of the bigger announcements and bigger companies that are putting big orders in for such vehicles.
So I actually have two questions, if I may ask two questions. One is for Jamie or Craig. So we spoke about sensor fusion and planning algorithms, perception algorithms. What about prediction algorithms? And are they a bottleneck towards autonomy today? And if they are, what's the kind of state of art in terms of development? Are we at the very early stages, or are we fairly well developed in terms of prediction algorithms?
If you don't mind, I'm going to repeat a previous answer I gave a little bit. I think that obviously the better that you can predict what somebody's going to do, the better that you can plan your next end steps ahead in time. But just like being able to predict that you're going to continue to be a jerk driver, or you're going to continue to follow the rules, or something in between, you can get it wrong. So I think that it's more of a comfort thing. Knowing that you're likely to slow down makes me more comfortable, because I can start to decelerate, me being the autonomous car, I can start to decelerate before you do, so that I don't have to abruptly decelerate. But I think that the prediction algorithms, I don't think, are necessarily as much of a game changer for being able to actually solve something like planning, as much as it is for the comfort. And hopefully I'm explaining myself well on what I'm trying to say.
And to add to that, I think a lot is about what are you trying to predict. And if I look at where controls is, so model predictive control, right, has been an exciting field, but when you want to apply it in an embedded control system, compute has been a bottleneck, right, in terms of the horizon you're looking at. What we've seen is with the growth in compute power and capability that we've been seeing over the last few years, is that we've started to use model predictive control in other parts of our business, but key to that is understanding what is it we're trying to predict, what's the horizon we're looking at. And I think if we take it too literally about trying to predict what's going on around us, trying to predict what every vehicle might do, that becomes kind of an unscalable problem very quickly. So I think it requires other thought processes, other techniques, and not trying to necessarily predict all the possible things that could happen.
Thank you. And the second question is for Chris. So about imaging radar. When do you think, or if ever, would imaging radar come close in resolution to LiDAR or even camera?
So I think that to achieve, it's going to certainly be on the trajectory in order to achieve 1 degree and lower angular resolution. But I don't think that radar systems are really going to be able to get to the 0.1 type of degree angular resolution of LiDAR. I just don't think that that's feasible from a technology standpoint. But I do think that there's a lot more runway ahead of us with these imaging radar systems, with cascading multiple channels to get higher numbers of virtual channels and different types of ways in order to get a larger aperture in order to drive to greater resolution. So, but again, radar doesn't necessarily have to get to the 0.1 degree angular resolution. If you have a LiDAR system, that can achieve that level of performance. Radar has another area. It works in inclement weather. You have Doppler, and so you can measure velocity directly on things like this. And so radar brings a lot more capability outside of just raw power when it comes to resolution that I think the system is going to benefit from. But still, having said that, I do think that radar systems are going to improve dramatically over the next decade in order to get closer to the 1 degree angular resolution, but in a cost footprint that's more appropriate to put 6 or 8 of these within the automobile.
All right, thanks. Unless there's another burning question, I was going to wrap it up. Okay, so I was going to briefly go down our panel, and any last thoughts on autonomy, and when do you think we're going to see, let's say, 200,000 autonomous vehicles on the road? Jamie, we're going to start with you. Give us our date.
Thank you for starting
Nobody's
with me.
taking notes, so nobody's going to take notes. Yeah.
All right, so I'll talk about what we've
Yeah.
publicly given ourselves as a goal. We're looking to go into production in 2022. We're likely going to be starting with smaller volumes, but this is not the small little showcase. This is mass production in late 22. I think to hit 200,000, I think it's going to be a very slow ramp.
Right.
I think that something that's different for automotive here is once you build a car, assuming that that it's homologated for a region, now you can spin out as many of those cars as you can sell. With something like AD, you have to keep up. The engineering, the development, and the validation has to keep up with the ODD. And if you have an ODD that's of size X, size X can only support so many customers. And so I think that we need to grow the ODDs, which is going to drive the sales. And so I think to reach 200,000 is going to be much longer than what we normally enjoy reaching 200,000 just traditional cars.
Yeah.
So
Absolutely.
maybe I can avoid your date
Yeah.
question because I genuinely
Yeah,
don't know.
no, not necessary if you feel uncomfortable. Thank you, Jamie. Craig, last comments?
I'm definitely not answering that question
Okay,
because I
good.
know that I'll be wrong.
I know they all wanted to know.
But I think what I would come back to is that if you look at other technologies that have been developed in the industry, they've been driven by the consumer and by competition. If you think about a level 4 or level 5 autonomous vehicle, we've talked here, I think, about inventing the technology, but we also have to invent the business model. And that goes to Russell's point about who's the customer, right? In a level 4, level 5 vehicle, you have got the person that's riding, but it's equally true that the city is likely to be a customer. And so that's why our approach has been with the work that we're doing with Argo in Miami, Washington, and Austin is to work very, very closely with the city and to work with other partners so that we can look at not just moving people, but with Postmates and Domino's and so on, look at moving goods as well. The retail side, of course, is quite different, right? And some of the traditional automotive pressures apply there. I think there's got an interesting intersection between the two when you think about autonomous parking, right? Which we haven't talked about here, but that is something that would be immensely appealing to a retail customer. Technically, it's a level 4 feature, but I think we can all see that the requirements for perception, path planning, etc., would be very different for an autonomous parking feature than they are for driving down the freeway. So I think the future is very bright for all kinds of autonomy. And I think if you ask the question around how soon could we see 200,000 autonomous parking vehicles versus 200,000 freeway driving vehicles, I think you get a very different answer.
All right, thanks for that. All right, Chris, last comments?
So my crystal ball is no better than anybody else's on the panel or here, but I think one thing that is for sure that the year is now 2020, and I think as we approach the end of this decade, the consumer base is probably going to be substantially different than the people that are sitting in this room today. You know, I remember a time in which there were no Apple iPhones, and now they've become such a fundamental part of how I operate my life. And so if I look at the next decade, you know, the consumer acceptance piece of this is going to certainly evolve because the younger generations are going to come up when they're going to be much more comfortable with these technologies. And also the improvements in the technologies are going to come up. I think that Craig brings up a very interesting point that some of these highly automated features like autonomous parking is also going to accelerate the building of trust around these things. I agree with Jamie. I think that getting to higher levels of fully autonomous vehicles is going to be a very slow ramp. But I suspect that over the next 10 years, you know, as the technologies mature and the consumers accept, there will be an increasingly accelerated adoption of autonomous technology. So there will reach a tipping point in which consumers are going to demand it. The business models are going to be in place. The technology is going to be capable. And I think that that's going to show a rapid adoption after that point. That might take another decade for us to really be in that position.
Thank you, Chris. Russell, last comments?
Yeah, I think, and thank you. I think, look, we're in, look in the mirror every morning. We're incredibly privileged to be in this industry at this time. You've got the size of the prize in terms of saving lives is absolutely profound. The size of the prize in terms of economics is incredible. The investment that's gone in the last 10 years has never been seen before. You're in a very, very privileged position where, again, you can make a mark on the planet. You know, not necessarily for this generation, for the next generation and those beyond. The challenge becomes there's two dimensions to this. One of them is business model and one of them is product. Both of them are shifting from traditional to non-traditional, right? In terms of product, we're going from, again, a traditional internal combustion engine that's been around 100 plus years. We're going to EVs and we're going to autonomous driving. When it comes, there is no date. Maybe the 200,000 comes between 2023, 2025, depends how aggressive the cities are, depends how aggressive the e-hailing fleets are. Right, I really believe that. And then in terms of the business model, again, we're going from a very traditional model where you've either bought or leased a vehicle to something where, you know, you can hire something for an hour, you can subscribe to something for a week, you can lease something for 2 years, you can buy something for a lifetime. Again, a whole spectrum of business models that are fundamentally different and changes to the dealerships too. So again, the parting shot is we're in a privileged position right now. Enjoy it and make a difference.
Thanks, Russell. Walt, bring us home.
All right, the last one. So I'm not sure about the time frame of getting 200,000 cars on the road, but you know, something we talked about is 37,000 people die on the road every year. And so I think over the next 5 years, we're going to see that number cut in half by the new technologies that we're bringing to market to go to level 5. And I think that's going to be the profound impact over the next 5 years.
Thanks, Walt. All right, let's give this panel a hand. Thank you.
So I wanted to thank everyone for coming and joining us in this event, and I wanted to thank the panelists for an absolutely outstanding panel at the end of a day. Just wanted to add a few words of thanks from ANSYS. ANSYS is a leader in simulation, and the role of simulation is very, very interesting. It allows our customers, you all, to build really innovative products, whether it is in the automotive space, or in building boats, or trucks, or ships, or rockets, or whatever, right? We enable our customers in all kinds of verticals to build innovative products. The value of simulation is actually in 3 broad areas. One is in reducing the cost of building the products, right? In the past, the products used to be designed on a CAD system. You had to build a hardware prototype, and it took a long time to do this. Then you sort of scale it out, and then you build the thing. Now, we are thinking of a future where everything will be built through software-based prototyping, right? So you, at some future point, you will not need to have a hardware prototype, right, at all. So the cost of building that product will be much, much significantly reduced. Second is the time it takes to introduce new products, the cycle time, right? I mean, car companies come up with a new product every year. Why? Well, it takes some time to come up with a new model and test the model and so on. Imagine a new car every month, a new car every 2 weeks. You could potentially reduce the time to build a new product very, very significantly through simulation. And the third thing is to enable you to build absolutely new innovative products, right? Why build one product per year, right? You can build 10 new products per year, et cetera, et cetera. So I think the future of simulation is very, very exciting. As CTO, I have the privilege of working on some exciting technologies. Some of the technologies I mentioned, AI, machine learning, right? Using AI, machine learning to accelerate simulation, to do all kinds of interesting things in this area, to do generative design, to imagine how new products will be created. The whole area of multi-physics simulation is exciting. Area of hyperscale simulation using high-performance computing to speed things up. The area of robust design is very exciting. Digital transformation, digital twins. So the future of simulation as a technology is, I couldn't be more passionate about it. And talking about the business areas, right? In the past, simulation was limited to certain sort of individual physics, whether it's the mechanical simulation, the structural simulation, the fluid simulation, and so on. Now the world is about the multi-physics, the interactions between the structural and the fluids and electromagnetics and so on. The new solutions like autonomous vehicles around EV, electrification, 5G, digital twins. I could not be more excited about this area. And CES is a wonderful place to talk about new technologies and so on.